Today we're going to be talking about section 7.5, which is called hyperbolas. Now, in order to get a hyperbola, what we do is we take our cone and we cut it vertically. So if this is our cone, we're going to cut it like this and like this. And you'll get two parabolas that go away from each other, which we call that a hyperbola. The actual definition of a hyperbola is a set of points such that the difference of the distance to the foci is constant. So we're going to have two foci again. When we're talking about distance, it's always absolute value. But if you were to find the distance to the foci, you subtract them for each branch, you would get the same number. So let me show you what this looks like. We have a horizontal hyperbola. They're very similar to ellipses, but they just go away from each other. You'll see what I'm talking about here. And we have a vertical hyperbola. So when we're talking about horizontal, it's going to look something like this. When we talk about vertical, it's going to look something like this. Now each one of these graphs still has a center. But now what we're going to do, ellipses don't have what's called a major axis. They have what's called a transverse axis. Transverse is kind of like the major axis. So each of these distances is a units long, and the length of the transverse would therefore be 2a units. If it's vertical, the transverse goes vertically. All right, next, well, let's write that down here. So the length of what's called a transverse axis is 2a units. At the end of the transverse axis, are what we call the vertices. And the coordinates of the vertices, we always start at the center, but if it's a horizontal hyperbola, it looks like we're going a units to the left and right. If it's vertical, it looks like we're going a units up and down. So the vertices are always on the transverse axis. Let's talk about the b value. The b value, it goes perpendicularly. And that's called the conjugate axis. And that's going to be 2b units. It's b in each direction. Alright, that takes care of that. The vertices are always at the ends of the transverse axis. And now what we're going to actually do, let me show you where the foci are. Foci, remember the parabolas always open up towards the foci. And the distance from the center to the focus is c units, just like always. So we'll talk about the coordinates of the foci. We always start at the center. And the foci are on the same axis as the transverse axis. So if the vertices are going left and right, our foci are also going left and right. If they're going up and down, of course, the coordinates would go on the y-axis. But then we have to, I'll show you how to draw this. Once you have a transverse axis and a conjugate axis, we actually box those axes in like this. I'm just making a rectangle. And then what I'm going to do is I'm going to connect along the corners of the rectangle. Like that. These are called the asymptotes. And then from the asymptotes, that kind of holds everything in check. So that's going to determine how wide or how narrow our parabolas are. So let's talk about the slopes of the asymptotes. Let's take a look at the horizontal case. To get this asymptote, start at the center, and we go up b and over a units. Up b over a. Remember, slope is always rise over run. We go down b over a units. So that would be the negative slope. For a vertical hyperbola, start right here. Let's look at the slope for this line. We're going up a and to the right b. And then we could go down a and to the right b. And that would give us the slope of the asymptotes. All right, so let's take a look at a few examples, and we'll be able to figure this out. By the way, just before we get going, a squared doesn't have to be greater than b squared. That's only for ellipses. So that's not going to tell us how to figure out whether it's horizontal or vertical. The way we figure out whether it's horizontal or vertical is by looking at the graph or by looking at the equation. A squared and b squared are always in the same spot. But in the numerator, if x comes first, it's horizontal. If x comes second, it's vertical. All right, so I know we're talking about a lot of components here. Let's take a look at a few examples. Let's say that if a is equal to 4, b is equal to 3, and we have a transverse that's horizontal, and the center is, let's say, 3, 2. Let's see, I think I said b is 3. I didn't write that. Let's graph it, and let's find the components. So if the center is 3, 2, it's going to be right here, 3, 2. We know that the transverse is horizontal, which means our equation is going to look like this. And I should have written down also that the equation tying everything together is just the regular Pythagorean theorem. Okay, so if it's horizontal and A is 4, that means we're going 4 units this way and 4 units this way. A is 4, A always goes right here. If B is 3, that means we go up 3 and down 3. So B squared is 9. And if our center is 3, 2, that's what the equation looks like. Now to actually graph this, we have our transverse and we have our conjugate, so we're going to box them in. And draw our asymptotes. Remember, we just connect the ends of the rectangle. It's a little weird to draw, but once you have your asymptotes, you draw your parabolas coming out from the transverse axis. That's what the actual graph looks like. The transverse axis and the conjugate axis, you wouldn't see that on an actual graph. That just gives our graph structure. All right, so as far as how long the transverse is, transverse would be 2 times 4 or 8 units long. As far as the length of the conjugate would be 2 times 3 or 6 units. Our foci, well, in order to figure that out, we know that c squared is equal to a squared plus b squared. And c squared would equal 16 plus 9, or c squared is 25, which means that c is 5. The foci would be over here and over here. Remember, they're on the transverse axis. So we would say that the foci coordinates would be our center. But we're going to be adding and subtracting 5 to the x value. So this would be what our focus coordinates would be. Okay, let's try some more here. What about if I gave you a problem like this? 2 more problems. Say we had x minus 2 squared, or I'm sorry, x plus 2 squared over 16 minus y minus 5 squared over 25, and that's equal to 1. Let's find the components and we'll graph it. First thing, we know our center is negative 2 comma 5. It's vertical because, actually no, it's horizontal, right? Remember, for hyperbolas, we're looking to see where x is. So this would tell us that we are horizontal. And what else can we find? We know that a squared is 16, so a is 4. We know that b squared is 25, so b is 5. Now let's start drawing this here. So negative 2, 5. Because it's horizontal, we're going to go 4 units this way, 4 units this way. B is 5, so we'll go in the opposite direction, 5 units. And let's see, the length of the transverse would be 2a, or 8 units. The length of the conjugate would be 2b, or not 2b. That's the question. 10 units. Let's connect by boxing in our axes. We'll draw something like this. Because it's horizontal, we're going to go to the ends of the transverse. Get something like that. And what else do we need to find here? Let's talk about what the slope of these asymptotes are. Now, if you drew it like me, you don't have to memorize any of this stuff. Just look at the picture. It looks like to get the asymptotes, we're going up 5 and over 4, or down 5 and over 4. All right, one more example here. What if I asked you to write an equation with the foci at plus or minus 7, 0, and the length of the transverse axis is 6 units. All right, so let's see what we have here. If the foci are left and right 7 units, that's the foci, and that means our parabolas have to open something like this, which means we have a horizontal hyperbola. Now, the length of the transverse is 6 units, which means 2 times a is 6. So a would be 3. So a squared always goes here. So a squared is 9. B squared, we don't know. But in between our foci, our center has to be the average. So the center would be 0, 0. So instead of writing x and y minus 0, we could just say x squared and y squared. We just have to figure out what b squared is. Well, it looks like we know that a is 3. We know that c is 7 from the foci. So if c squared is equal to a squared plus b squared, we would get 49 is equal to 9 plus b squared, or b squared is 40. That would be our equation. All right. So for homework, what I would like you to do is on page 445, please try numbers 11, 15, 19, 21, 29, and 37. Thank you very much. Have a nice day.